Hello, dear students. Today I am going to start a new course, not a course, a series of talks which I will call Calculus Minis. It is one of my first attempts to start a popular series of lectures on calculus, a kind of extension to my NPTEL courses, which many of you have seen and many of you have actually liked and many of you have written to me. So today we are going to start with this question. So calculus minis I should write maybe part 1. So today we are going to ask what is the meaning of the term integral a to b fx to dx where f is from R to R. Whenever we talk about the integral, immediately in our mind comes this picture. That here is a function from the point drawn between the point A and B, and we try to compute the area which lies under the curve between the points A and B, and we said suppose this is my required area, and we say the area is equal to integral a to b f of x dx. But I want to ask you that when we do that, do we realize that when we are drawing this function fx, I am always considering the function to be non-negative. And that makes sense of an area because area as a magnitude has always got to be non-negative. It cannot be negative. So if I don't have the function f, if f need not be if f need not be if f need not be a non-negative function, then what is the meaning of the integral? Then what is the meaning of? That is the thing that we want to answer. Because you see, if this integral, if this function is non-negative, you can still say, okay, there is area under the curve. Okay, I can take this area, I can consider this area and add up the areas and say, okay, this will be the area under the curve. Of course, you are not completely off the mark. But let us see how do we actually define a function as an integral of a non-negative function. So let us look at the very definition that we already know when we start doing integrals. Because when we do integration theory, we hardly think that we are talking about non-negative functions. We just think that is an integral, there's some function and the area under the function is the integral. But the question is that many times we forget that we are dealing with non-negative functions. So if I do it now just for non-negative functions, so how would my area be defined? What we do is we divide this zone AB into several partitions. When you partition the zone x0, x1, x2, and so on and so forth to xn, so to n points. At each in each of these intervals, which I write like this, xi minus 1 to xi, or xi to xi plus 1, whichever, the ith interval, for example. So this, so I is varying from 1 to n. So I have these n intervals, and hence I have n plus 1 points. In these n intervals, because this function fx is now non-negative, what I do, I tag each interval with some point. In the first interval, I tag a point, say x1 dash. The second interval, I tag a point x2 dash here. Some point I tag. These are called tags. And the nth interval, I have xn dash. Okay. So what I do, I construct this sum. That is the sum of the areas. Basically, we are constructing rectangle with this particular height. So rectangle here. So this is the kind of area we are figuring out. And when you have this is the tag point. So we are looking at the height here, and then we are constructing a rectangle over x1, x2 with this height. So that is what we are doing. Okay. So what we are doing, so my height, length of the rectangle is the function value at the tagged point, and then is the length xi minus 1, because xi minus 1 is always bigger than xi. Here obviously b is bigger than a, and that goes from I is equal to 1 to n. What I do now is, I would say that what I get is an estimate of the area, not the actual area. We overestimate in some points, we underestimate at some parts. We will get closer and closer to the area once we put more number of partition points, right? So basically, as we increase our n towards infinity, that is, we have more partition points, right? So if this limit exists, then this limit is called the integral from a to b of fx dx. So this actually is the area under the curve, because this is a non-negative function, because this definitely defines the area of a rectangle, because the area always has to be non-negative. Because if this quantity is always non-negative, because xi is bigger than xi minus 1 and f of xi dash is always greater than 0. What happens if the function need not take non-negative values everywhere? Can we define the integral? This is where you make a leap in the imagination. So what is that leap? Leap is that, can I keep the same definition, but when I have a general function, I'll use a very important trick which every student of mathematics or every student who uses mathematics should know. So if you take any x element of R, then x can be written as always as the difference of two non-negative numbers, x plus and x minus. You can try it out with any number. I'll not do, you can do this experiment, where x plus is the maximum of x and 0, where x minus is the minus of the minimum of x and 0. So this is greater than equal to 0. So this is also greater than equal to 0. So what is happening is that any number, real number, can be expressed as the difference of two non-negative numbers. You can always do this. So once this is done, So given any function fx, I can always write it as the difference at any x. The function value is a number, real number. So it can be expressed as the difference of two non-negative numbers, and the choice of that non-negative numbers is not unique, but it is it depends on the way, it depends on the chosen x that you are choosing in AB. So it can be also written as f plus x minus f minus x, where f plus x is the max of fx and 0, and f of minus x is the minus mean of fx and 0. So now if I look at this particular sum, f of xi dash xi into xi minus 1 I equal to 1 to n. Now this sum can be written as summation I is equal to 1 to n. So this is a non-negative function, this is a non-negative function for which there is a natural definition of the integral as a area under the curve. So I can write this as f plus xi dash minus f minus xi dash into xi minus xi minus 1, and this can be again written into two different sums, f plus xi dash into xi minus 1 minus summation I is equal to 1 to n f minus of xi dash. Xi dash is the tag point, not a derivative, please understand. It's just a tag point, is of just a point chosen in the interval xi minus 1. So we can have this. Now, so the limit, suppose the limit of these two exists, and hence the limit of this exists. So limit n tends to infinity. Suppose the limit of this exists, of this quantity exists. So these quantities must also have limits. So limit n tends to infinity, I am assuming that it exists. We suppose that. So it implies that these two also say individually must have limits, otherwise the limit of this whole sum cannot exist. So what we now have is that limit of n tends to infinity I is equal to 1 to n f of xi dash xi minus 1 is same as the limit of summation I is equal to 1 to n f plus xi dash xi minus 1. Actually, I am just writing limit n tends to infinity in the sense that as I put more and more points, you can actually make the length of the intervals, smaller and smaller and smaller and smaller. That's the whole idea. So you have more very rectangles with very small breadths, small bases. So gradually we'll go nearer and nearer to the area. So this whole integral is limit of this minus limit of this. But we know that these are sorry, no, I'm making a mistake here. Let me just find out my, eraser, and I just erase this part. Let me get my pen and we do this auto minimize. So I'm also learning this skill. Oh, sorry. I have to get the eraser, erase this, get my pen and put the minus sign, right? So now f plus is a positive function, non-negative function. F minus is a non-negative function. And you know that this limit is nothing but the integral given as an area under the curve f plus x. This is under the curve f minus x. So I can write that this is nothing, that this limit is finally the integral from a to b of f plus x dx minus integral of a to b f minus x dx. So now we can say that the integral of a general function, which can be defined as, so integral of a general function f, integral of a general function can be defined as follows: integral a to b fx dx is integral a to b f plus x dx minus integral a to b f minus x dx. So what we have done, so the integral, so what we have done, we have now shown that the integral for a general function is the difference of two areas. Difference of areas. Sorry. I think there's some, I'm also under the learning curve. So here also I think I have to make it look much more nicer. So what we are having is, there is some problem that's going on. So integral is not just an area for a general function, it is the difference of two areas. So this is something we really have to keep in our mind, that the integral is really the difference of two areas and not in general just the area under the curve. So area under the curve only for non-negative function, and the difference of two areas when we are talking about a general function. So now let me proceed, right? So I am also learning to write in this mode, so please forgive me for some little disturbances. Now let us take an example from mine. Integral from minus pi to pi sine of x dx. Many of you know calculus would immediately know the answer is 0. But how do I get the answer 0? Can I put it in the format that we have just discussed above? So what is sine of sine x plus? It is max of sine x 0. So in the interval 0 to pi, this is greater than equal to 0. So this can be written as, so sine x plus is sine x when x is in 0 to pi and is equal to 0 if x is otherwise. If x is in say minus pi to 0. Okay. So this is what we know. What is sine of x minus? Is the minus of the minimum of sine x. So what is sine of minus x? Sine of minus x is equal to sine of x minus is equal to, so when is sine x strictly less than 0? When it is between less than or equal to 0. Sorry. So maybe I have to invoke this is the duster actually here. So now we take the chalk again and start writing. So it is minus of sine x provided x is in minus pi to 0 and 0 otherwise. When it is 0, it is 0. So this is what I have. This is what you have. So sine x is negative in minus pi to 0. So if you look at the graph, minus pi to plus pi, this is your sine x. And my drawing may not be very good. So the area, those two areas under this part and this part looks very symmetrical. So this is a sine x spot. So if I want to integrate this by the way I have learned just now, so minus pi to pi sine x dx is equal to minus pi to pi sine x plus dx minus pi to pi sine x minus dx. And this can now be written as follows. Oh my goodness, what has come here? Okay, just forget it for a moment. It's gone. So this can be written as 0 to pi sine x dx minus pi to 0, because this is how we are using the definitions here, minus of sine x dx. Now look at the graph. So between minus pi to 0, minus of sine x would be, if this is minus pi and this is your plus pi, so this is a minus pi, then your minus of sine x has this graph and sine x has this graph. Because of symmetry, these two areas are equal. So this area is equal to this area. So if this area is A, this area is also A. So basically these two areas are equal and they will cancel out, they will give me 0. So this, what we already know. So from this standard, the definition that we have learned, from that also we can now write, we have proved that by using the definition that we have provided for a general function, this would become 0. So it is very important to remember that the real interpretation of the integral is that in general the integral is the difference between two areas. When we talk about area, we are always talking about non-negative function. You can say, okay, I can talk about non-positive function. Then if you take function which is always less than or equal to 0, for example, if you are talking about a function like this, can we define an area? No, the negative of the integral will define area, because the area would be always positive, because the function value here is always negative. The area value is always non-negative. So then if you take a non-negative function, a non-positive function, fx is less than or equal to 0, that the integral of such a function is a negative of the area. The negative of that integral is actually area. That the integral is not the area, right? So please understand that when you talk about the area under the curve as an integral, the integral as an area under the curve, we are always talking about non-negative function. In general, the integral actually means, what we have just learned, is the difference of areas. This is the key thing, key learning today. With this, I would like to say a goodbye and hope you enjoyed it.